Hello, and welcome to the WIDS Upskill Workshop Series. And this is our session for today, Wednesday, May 8th. Let's get started. Before we get into the material from the instructor for today, let's highlight a few items. So please use the QR code on the slide to get access to the pre-work instructions for this workshop. So this is a hands-on workshop. We'd like you to participate, and please scan that QR code. And let's continue where I'll give a brief overview of myself, but also highlight information about our instructor. So as a part of this particular session, welcome and greetings for today's upskill workshop. My name is Lavia Walker-Hannon. I will be your moderator today. I'm an application engineering senior team lead with MathWorks, a WIDS workshop, a next gen committee member. And as a part of my role with MathWorks, I assist customers with using MathWorks tools with respect to AI, data science, remote sensing, and other similar applications. I also manage a team of several engineers as well. And just related to our workshops for today, I'm extremely excited to be your host. And let's actually move to the next slide so we can start to get into information about the instructor as well as the content. So it is with great pleasure that today's upskill workshop will be presented by Dr. Garima Sharma with MathWorks, and I will highlight her bio next. So Garima is a senior application engineer with a signal processing and machine learning background. And one of the items that stands out for me is, these items that Garima's highlighted. Every day, she works up intending to add some knowledge to her skills and improve a bit as a person. So for her, learning is an everyday practice. Her core engineering skills have helped her to gain business intelligence, and during her journey as a PhD fellow, helped her to feel the power of signal processing that could be used to solve a variety of real world problems. During her previous experience as an assistant professor in engineering, she has excelled in her people skills and presentation skills. And as a PhD fellow, she has improved her technical and soft skills. In her PhD work at Toronto Metropolitan University, she was focused on finding the biomarkers or discriminatory handcrafted features in audio and image data using her signal processing knowledge. Her work revolves around finding the convinced but meaningful information from the signal that makes the signal suitable for a variety of different types of analysis, typically machine learning analysis, classification, and regression tasks. With that introduction, we have Garima, who will deliver the workshop Low-Code Data Analysis with MATLAB. I know there's an emphasis on Excel users, but a variety of users could also benefit from this information. With that in mind, Garima, we welcome you. Thank you.
Thank you, Louvair, and welcome everyone for this workshop. And today we would be talking about a lot of good stuff. Let me share my screen so that we can just kick off. Okay, so today let's kick off with our topic agenda today, where we will be discussing about the low-code data analysis with MATLAB. So moving forward, we would be discussing how the MATLAB desktop and the editor looks if MATLAB is something new for you people. And we will be seeing how the low-code approach or the live task can be integrated within the MATLAB ecosystem to ease the human efforts. There are several ways how we can import the data and handle the missing data and the noisy data. We will see how we can, with low-code approaches, we can do the data visualization. At the end, we will see the few of the helps and resources which are present for you from the MATLAB. Okay, so few of you might be new to MATLAB, and for them, I'll just give a very high level of introduction. MATLAB is a high-level programming language. This is suitable for engineers and data scientists. On top of that, this is a very interactive environment. The base MATLAB, it can be extended with various toolboxes which are designed specifically for different applications. Currently, we have more than 120 toolboxes available. It can be used for very quick analysis of the data to develop programs for the production-ready deployment applications. Now, when we talk about the data analysis, which is a part of many data science-based projects or in the data analysis-based projects, the basic workflow that the MATLAB supports is we need to start with some kind of data. Now, the data could be present anywhere. It could be on your laptops as the stored files, or there could be a external database or a software which is generating real-time data. Or you might be working with the real hardware where the sensors are deployed and you are getting the real-time data. Now, all kinds of data MATLAB can access and can bring into the MATLAB's ecosystem. Once the data is there in the MATLAB's ecosystem, we can explore and discover the data by performing various data analysis approaches and creating our own models. The algorithm development is very easy with MATLAB ecosystem. And once the algorithms and the data analysis is done, we can create dashboards or applications for the development purposes so that these can be shared with the other users, which are MATLAB users or might not be MATLAB users. So once we explore and discover our data, we like to share it in the form of the reports or documentation with our peers, or we want to deploy it for the further design. Maybe we want to convert it into a C or C++ for hardware deployment or as a standalone executable, or maybe a dynamic library for Python. All these things present in the workflow are possible in MATLAB. Generally, it looks like this is a linear this is a linear process, but in reality, this is an iterative process. And in MATLAB, there are so many ways how we can automate right from accessing of the data to the exploration and towards the sharing of the data. Now, moving ahead, uh, there are several advantages while working with the MATLAB-based documentation. So we can document as we go. For example, on your screens, you are looking at the live script where the outputs are reflected at the same time when a cell or when a section is run. We can add rich text formatting like equations, images, and hyperlinks into those live editors. We can also include few of the animations and embed several controls and export them for future use. We can write down programs to control the fonts, and we can save it, export it directly to the PDF, HTML, Word files, or the LaTeX files to share it with our peers. Okay, we know that the algorithm development it grows with time. So more and more people are now doing the algorithm development, and it is getting really complex. But we will start with very simple. We will see how the MATLAB language grows with you. For example, if we want to divide the two variables a and b, it's very simple. So the a and b can be divided just by a backslash. We can create scripts as well in the MATLAB ecosystem. Once the scripts are ready to call them as a reusable functions, we can convert them into functions so that they can be called several times. And once the functions are ready, they can be integrated with the class-based or what we call as object-oriented programming, where it becomes more robust. Now, because we were talking about the basics of the MATLAB, I will like you to walk through the basics data types which are present in MATLAB, and this is how we grow. Now, for example, we can create arrays manually by doing some kind of programs by using colons or line space, or maybe we can use few of the built-in functions. There are all the possible ways how we can manipulate these arrays by using indexing and the various concatenating techniques. So we start with the smaller single value, which is a scalar, and then it grows like a row vector or a column vector, and it grows further into the two dimensions and looks like a matrix. And once the matrices are there, it can be converted into the table, or if you are working with the time series data, it can be converted into the time data or the timetable, which has some timestamps included. Okay, so why not to fire up our MATLAB right away? I'll share my MATLAB screen now so that we all can look how actually the MATLAB and our first exercise looks like. So I ask you to open the task one from the exercise.mlx file. which is right here. And I believe you can see my MATLAB. For those who are familiar with MATLAB, you might have seen. So currently I'm working with the MATLAB online version where I have shared the full data with you. Now, just to give you a high level introduction, the MATLAB's structure is like you can see how the source of the files is coming from, which is like highlighted. In the middle of the screen, this is my live script that you and I will be working together throughout this session. At the bottom here, we have the workspace where all the variables that have been created are stored. And here at the bottom, there are command windows. Command windows are the way you can see the results, and these are also the way you can see the errors as well if they are happening. Errors are bound to be a part of our algorithm development. Now, before jumping into the exercise one, and we started with the task one, I would like you to introduce to one of the fantastic applications that can be used for creating the dashboards or the interactive apps. Now, for example, today we will be working with one of these apps. Now, what this app is doing is, in this app, we have a slider that can be used to check the or to choose a particular value. We have a axis where the figures can be populated and few of the push buttons that have some certain functions. So today, we will be working with a demo example where the energy forecasting function will be analyzed. For that, how this function looks like, let me load the data set first. So today we will be working with data which is not the completely clean data. So that's why I have given it the name data underscore dirty dot CSV. So that's an Excel sheet that we are working with. And let's see how this data actually looks like. When I populate this data, you can see there are three major variables: hour of the day, temperature of the day, and how much energy is consumed or power is consumed in megawatt. My aim is to find out a kind of model that can help me to predict the future consumption in power if the temperature and hour of the day is given. I have some historical data, and now that data has to be fitted on a curve so that we can do the successful predictions. Now, if you look at this curve, oh my God, not all of the points are well fitted on this hyperplane. What we can do, we can start from, we can start the polynomial order by choosing the slider. Currently, this is linear. Now let's see if I change it from linear to quadratic, how does the fit changes? This looks better. Now more and more points are present on my hyperplane, so that means the curve that we are fitting, this is quite better than the linear one. Based upon your data, you can create these kind of apps by yourself, and you can, without even going into MATLAB, the whole analysis can be done by these kind of dashboards. Now, these dashboards are very powerful. You can also maybe generate reports here. In this case, I am creating a new report, which is here, and that report is now saved into my current folder. So this is where the report is. Now let's see how this report looks like. So let me open this report. And see, this is an auto-generated report which is powered by MATLAB, and it will give us a high level of contents, what I'm doing, and how I'm visualizing and reporting the data. This is how my energy forecasting function looks like, and that was the subset of the plotted data that you have seen. This is just a sample that how the automatic report generation can be done, but this report generation can be very sophisticated and can be very detailed. All right, now let me bring you back to our exercise, which is let's perform our task number one. This is a live script that you are looking on your screens. There are a few hyperlinks that are generated. So these hyperlinks can help you to move within this live script. Now, our first topic is to get familiar with the MATLAB desktop and editor a little bit. For those who are doing it for the first time, this is my task one, where we will be dealing with handling of the scalar units. Now, We can generate scalars, and the aim for this task is to make you familiar with the mathematical operations such as multiplication, division, subtraction, and addition. So what we are doing here, I have created two variables A and B and given some value. And what I want is from you is to just do a little bit of practice and create a new variable C, which is based upon the multiplication of A and B. Just very simple one. And in MATLAB, if you put a semicolon at the end of the equation, it suppresses the output. But if you're leaving it open, it will show you the output. Now, similarly, we can update the variable. That's the second part of the task. And the code is given to you with an equation a square plus b. So you can follow along with me and see how it looks for you. So c is a square plus b. So I'm suppressing maybe the first output here and want to see the second one. So this is a small section. And to run this section, there is a blue bar on the left that you all can see. So what we need to do is just hit the run button here, which is the blue bar, and you will see the output. So here you can see the output C, which is 13. So the output of the first C variable is not shown here in the output, which is right here below, because I suppressed the output by putting the semicolon. But for the second C, where I'm updating the value of this variable, you are looking at the updated value of C, which is in this case 30. Now, this is how the scalars are handled within MATLAB. Let's get a little bit more complicated and start generating vectors. So vectors are either it can be a row vector or a column vector. There are several ways how we can handle or generate these vectors. The one of the way is by using the columns, and the second way is by using the inbuilt function like linspace. So when I run this, you will see that, okay, when I want to create a vector starting from 1 and the ending point is 20 with a step size of 2, I will use a colon operator so that I can mention the step size and the start and the end point. But if you are not sure about the step size, but you are sure about the number of elements that you want into your array, the linspace is our second option. So again, our starting point is 1, the ending point is 20, and I need 5 number of elements in this array. So we can use, we can use linspace like this. Now, your task is to just replicate this linspace and use it for creating 100 elements in the array from the range 1 to 50. I'm doing it with you, and you can also follow along. We can doing linspace starting from 1 to 50, and I need 100 elements. And when I run this section, you will see all the 100 elements down there in your live script, which is ready. Okay. Now, we got some familiarity between the scalars and the vectors. Now let's see how we are handling the matrices or the more complex data. Matrices are like a two-dimensional data. There are ways how we can do that. Now, for example, in this case, I have generated a matrix A by where the rows are separated by the column. So I got two matrices A and B. Now, because MATLAB, it stands for Matrix Laboratory, so that means the basis of the MATLAB is the matrices. So all the data, whether it is a one-dimensional data or a multi-dimensional data, MATLAB looks like it in the form of a matrix, and all the matrix operations are possible, like getting a transpose, doing the matrix addition, or performing the matrix multiplication. Let's see how it goes. Beautiful. So we got our first matrix here, which is A. The second matrix is B. And here I got the transpose where the rows and columns are flipped by using a transpose of the matrix. Why it is going up again? And then we are performing matrix addition. So it is element by element addition of the two matrices A and B. And then I have two additional matrix multiplication where I generated another matrix E and another matrix F, and perform the multiplication of E and F and pass it to the variable G. Now we have seen that, okay, that we got some variables. So just to make sure how our workspace looks like, you can actually look here. Now my workspace is being populated with all the latest variables of all the latest values of the variables. So that's the role of a workspace to save all the variables together. Now we got some idea about the matrices as well. Matrices, like for example, few of you might be working with the image data. The images are stored as a two-dimensional matrices in MATLAB. Now, there are other ways how we can create those matrices by using the built-in function. For example, if we want to create a matrix of size 3 cross 3 with ones or 4 zeros, we can create it by using the inbuilt function. There is another good function, internal function, which is the magic one. But before I explain what the magic is, let me run this section where you can see that, okay, the matrices are generated by using the internal functions like ones, zeros, and this is how the magic looks like. Now, if any one of you are familiar about this magic matrix, please put it in the chat if you know that what this magic matrix is and what it does. If you are not familiar, I'll give you an idea. This magic matrix is actually gives you the same number. If you do the sum every column, it will give you the same number. Or if you do the summation row wise, you will get again the same number. Or if you do the summation diagonal, you will get the same number. That's all this magic is about. So that's just an example. There are many other built-in functions that can help you to handle the various kinds of data, whether it is a scalar data, a one-dimensional data, a two-dimensional, or even three-dimensional data. Okay, so I believe you all have completed your task 1. And if there are any questions, you can put it in the chat. There are TAs and the help available for you. Now, once we have the data in MATLAB, there are several statistical analyses that we can do. That could look as simple as finding out the maximum or minimum from a matrix to the average, median, standard deviation, and for the more the complex analysis like finding out the variance and the ANOVA methods. All these kind of descriptive statistics can be calculated based upon the matrices. Now, just like any other programming languages, there are several ways how we can index the matrices in MATLAB. We can do the indexing by position or by doing the linear or logical indexing. Now, once we talk about the data, MATLAB can handle any kind of data which is present in this ecosystem. That could be as simple as having an Excel sheet or a CSV file, or it can take the data from the MySQL or the other kinds of sequential databases. You can also handle the big data formats like Parquet or the special formats like HDF5 files. Also, there are so many other ways how you can handle the various types of data and from where it is coming up, whether it is coming from your laptop or from a cloud-based, maybe SWS, maybe Amazon S3 buckets. Now, there are over 100 low-code tools for data analysis, which is present for various data analysis, engineering, and AI methods. Today, we will see few of those low-code tools which are present. Like on the screen, you are looking at the Deep Network Designer app. That is again a low-code tool for designing the deep neural networks for AI-based applications. All right then, let's try out our task 2A. So please open your exercise.mlx file and which is here. And we will start working with our task 2A, which is about loading the data and the data visualization part. Now, what we are looking here is this is a live task. The live task might be already there in your exercise, but from where it comes, maybe I'll just delete this live task from here and will show you how I get this. So you can start working. You don't have to delete it. You can just follow along and see. Now, on the top of the breadcrumbs here on the MATLAB, from the live editor, there are live tasks which are available. Okay. Oh, I can't pull this live task for some reason, but what I can do, the live task is there. So this live task is actually the interactive way of handling the data. Now, what we can do, we can just browse the data, which is present in our resources, which is present in our working folder, and the data is data underscore dirty.csv. And we just open this file. Now, once the file is there, it is a CSV file. MATLAB will automatically sense the kind of file it has, and it will ask us what kind of output format do we want? Do we want, if it has a timestamp, do we want to convert it into a timetable that can handle a time series data, or just a simple MATLAB table, or maybe column vectors? But for this exercise, let's keep it to the timetable. And we are exporting the data and saving it into the variable TT data, maybe timetable data. And if you look here at the output, this is how your timetable data looks like. We have over 8,000 rows and 3 columns. So the first one is our timestamps. So it is not taking it as a column. So the columns are holiday, power, and temperature. This is what the historical data which is provided to us for our today's example, where the power and where the temperature is given to us, and we need to find out the power by using the curve fitting approach. Okay, now we have the data TT data. Supposedly, holiday is a logical data type here, where 0 means it is not a holiday and 1 means it is a holiday. But maybe for our analysis, it might be interesting to you to drop one of the columns that doesn't make sense for the further analysis. And for that, we can actually choose, we can come to the next section where I am choosing only the 2 columns, which is power and temperature, and getting it from the time series data or the TT data and saving it into a new variable, which is right there. Okay, something weird. All right. When we run this, you will see that now we have a new time series data where we have the timestamps and the holiday column is now dropped off. So we have power and temperature for further analysis. So that was our task 2A. Now let me jump back to my presentation so that we can go forward with our next task. Okay, now once the data is imported in MATLAB, the Excel is there. Now we have the time series data. Now we want to do some kind of data visualization on that. There are several kinds of plots which are available, like stacked plots, histogram, pie charts, word cloud, and many more that can handle various data types. We can annotate those visualizations and can export them as the functions to perform the data visualization on the other kinds of data as well. For example, the example you're seeing on your screen is a histogram where the annotation, such as the highest horsepower, is mentioned there. There are pie charts available and the stacked plots. We will shortly see what a stacked plot is and how it is helpful. All right then, now let's jump to our task 2B. Okay, our task 2B is about the data visualization part. Now I'll share you don't have to follow along the thing that I am showing you on the screen, but what I wanted is just let's see how it looks like when we talk about the quick data visualization part. Now, if you see here on the workspace, there are times table. What we can do, for example, I selected one of the variables from the workspace, and if I go to the plot section here at the top, automatically MATLAB will see that, okay, you have a kind of data or a variable selected, which is a time series, and maybe a stacked plot could be a good option to see how it works. And we can choose the plots right away from the recommendations given by MATLAB. Okay, let me see what's happening, why I'm not getting the plot here. That's interesting. Uh, we just need to select this one with the TT data, but okay, maybe while we are working on the Zoom and on the online version, there might be something that is mismatching here. But there are other ways as well. For example, if I come back to my task here, which is task 2B, I have added one simple plot command here, which is the stacked plot. Let me keep it full screen. And when I run this, it should give me a stacked plot right here at the bottom. Now, this is a stack plot that works on the holiday, power, and the temperature. So the stack plot means the timestamps are taken as a base, and all the plots with the same timestamps are there on your screen for a better visualization, where you can see that, okay, whenever there is a holiday, what is the power consumption with respect to the temperature? Those kind of deeper analysis, it can be done while doing this stacked plot measurements. All right, then. Now let's come back to our presentation where we can see that how the task 3 looks like. Okay, then. Now, once the data is there, we have imported the data, we have seen some kind of visualization. We might see that, okay, there could be some kind of noisy data which is present. Maybe the data is missing or there are some outliers that can bias your data analysis process. In MATLAB, there are several live tasks which are present, such as clean missing data that can help you to fill or remove the missing data. And similarly, few are for the cleaning outlier data. There are several statistical methods that are supported to handle these kind of noisy conditions. All right, then. Go to our task 3 and 4, where we will see how we can handle the missing data and how we can handle the noisy or the outlier data. Okay, let's jump to our task 3. In the task 3, there is again an interactive window in front of you, which is a live task. Now, this live task is used to clean the missing data. So what I have done here, from the original data, which is TT data, we need to specify a variable, which is power, that has some missing values. And what I am doing is I am filling those missing values by performing the linear interpolation. There are several other methods which are available. Maybe you can try those methods if you have some time. Say, fill those missing values by a moving median value or by a constant value. So for this, my task, let's stick to the linear interpolation. And what this code looks like, if you see here, this is what it is happening under the hood. We are using few of the inbuilt functions like fill missing from the MATLAB, and we are filling that by choosing the data variable power and by selecting the linear interpolation method. But let's hide this code. We don't want this because everything is done by MATLAB by using an interactive environment. Now, when I run this, you will see here the output. Now, this is how the power graph looks like. And all the red dots shows you the filled missing entries. And you will be amazed to see that there are 419 missing values which are present in our historical data that has been handled within few clicks by using our MATLAB's interactive live task. Now, you can see maybe just the filled missing entries. Now, if you see not the data, but just if you want to see where those missing entries are, those are all the missing entries which are present. So depending upon your need of the data visualization, you can modify these live tasks. And now with the newest MATLAB, you can create your own live task as well. So once a data pre-processing method is there, you can create your own live task so that you can repeat the data cleaning methods again and again whenever a new data arrives. So that was my task 3, where we handled the new data, where we handled the missing data. Sorry. Okay, so let's jump to our task 4, which is handling the outlier data. Again, you have seen that we have a live task to handle the clean outlier data. Again, I know that there are several outliers which are present in the power. And in this case, I don't want to fill that. Let's remove those outliers. And how the outliers are defined, there are several ways how we can do that. Maybe you can change the thresholding factor or the detection method to see how the number of outliers are changing for you. Now, what I did here, when I run this, you will see that, okay, there are 81 outliers which have been cleaned. And again, if we want to see all of the data together, like how my input and outliers and the threshold looks like, we can select all the display results and you can see that, okay, these are the whole, yeah, like input data or how it looks like and how the clean data looks like. So the number of outliers cleaned for me is 81, but this can be handled if we are defining or if we tweak the define outlier parameters. So that was our task 4, which is handling of the outlier data. Now, let's hop off from the MATLAB and go back to our presentation where we can move forward with our next topic. Okay, now remember we have seen an app at the starting where we have seen that how the energy forecasting can be done if we have a three-dimensional data like hour of the day, temperature of the day, and the power. So we have the historical data and our approach is to find out a curve which fits these data points and can help us to predict how our next power consumption looks like if the temperature and the hour of the day is given to us. Now, let's try out our next task, which is task 5. Okay, now before I go to the task 5, I need to do some kind of data preparation here. So for that, I have already done this part where what I'm doing is I'm getting the time of the data in the form of the month and day and just saving it as day of the month, day of the week, and the hour. So all those functions are present within MATLAB to handle the various kinds of timestamps. If you are working with time series data, it might be a good idea to analyze your data, how it is changing every hour, every day, or every month. That's why all those parameters are important. And for what I want from you is everything is done here. You just run the section, explore the data, and you will see here that how the hour of the day and the temperature, it looks like when the box plots are plotted for the power. You will see that, okay, there are certain times of the day, maybe from where are like the middle of the days, the power consumption is more in comparison to the early mornings or maybe late nights. We can add the labels to this kind of visualization to make it a little better. So if it is commented here, I just take the comment off and so you can understand that how you can add labels to your data. Now, going further down, there are several other kinds of data explorations that you can do. For example, I need to see a box plot where the power and the day of the month is chosen. And for this, oh my God, what's happening? Okay, and for this, when we run this, you will see another box plot that gives you an idea that over the month, how the power consumption is changing. Now, in this case, you will see that there might be few of the patterns that you might figure out, or there might not be few of the patterns, but it's a good way to handle the various kinds of timestamps and do the analysis. Now, again, for example, we want to do it with respect to day of the week. In that case, you will see that, okay, on Sunday and on Saturdays, the power consumption is little less in comparison to the rest of the weekdays. Maybe a good analysis for you. Going further, you can see the power versus temperature one, how it looks like. Now, we are coming to our task 5, which is using the curve fitting. And for that, I need to do some kind of pre-processing where I am modeling the hour, temperature, and power of the data which is present. So for the time series. Now what I need to do is I need to use this power into the app. Now if we go here at the top, there are so many apps which are present. For our task, we are going to use the Curve Fitter app. Okay. Now here you can see the Curve Fitter app is popped up. What we need is we just need to select the data. Now the data is present in the form of X, Y, and Z, where we have model R on X-axis and similarly model temperature on Y, and we need to see how the power looks like. So from all the variables, we are selecting the power. We are selecting it from there. And we just close it. Now, this doesn't look like the actual curve that we have seen because in this case, there are several kinds of work like fit types which are available. In the app that I show you was the polynomial one. Now, this is how the polynomial looks like, but this is the linear one. What I show you is I showed you a quadratic polynomial that fits the data, and this is how it looks like. You can see now this is a high degree of polynomial that fits the data. And in addition to the fitting, you will get a lot of statistical information that might be useful for your case. Maybe you have the polynomial fit equation where all the coefficients that have been predicted, their values, their upper and lower bounds, and the goodness of the fit, they are present. These kind of additional statistical values are important while we are doing the explainable AI kind of thing, where we want to say that, okay, why this curve fitting is good and why one particular curve fitting is not good. So what we can do, the beauty of using MATLAB is whatever you have done in this app, you can generate a code from here. So what I'm just generating a code from this export button and oh, okay, okie dokie. All right, so let me minimize this, but I have that code generated already, which is in the present, which is here, create fit. Now that code which has been generated, I have already saved it for our. All right, that's weird, but let me check if we can handle this. Okay, I had a create fit here. Now it should be okay. So this is currently running. So that's new to me as well because I had a I had my create fit function which is saved here. Okay, perfect. It might be something which is like over the Zoom or something happened. But okay, I had a function create fit that I have created from my export function where the model R, temperature, and the power is given as the output. And I got the fit like this. Now you can see this is exactly the same fit that we have seen in the app or we have seen in the inbuilt app with all the statistical results. Now, our task 6 is to find out what should be the estimated power if the time and the time and the temperature is given to us. So for example, at 12 noon, if the outside temperature is 25 degrees Celsius, the estimated power consumption might be near to 72. And if we want to add some confidence level, so you will see the upper and lower bounds. So this is how a simple data analysis can be done by using MATLAB with a no-code or low-code approach where you have not written any code, but the whole data analysis part is done by MATLAB. Now, I would like to summarize what we see here. Okay, so we have done our task 5 and we see that how we can access the CSV file from our laptop. We have performed some data analysis and the basic modeling, and from the app itself, we can do the report generation. Now you can share these results in the form of the live script as such because it has all the inputs and outputs as well as from the PDF reports that you saw. I introduced you to few of the apps like Curve Fitting app. You can create your own app, like I show you in the beginning of the discussion, and package it as a maybe standalone executable and deploy it on your own systems. There are several kinds of deployment tools which are present. Like if you want to deploy it on a hardware, maybe you can use MATLAB Coder. If you want to create a standalone executable, maybe we can use for MATLAB compilers, for Docker containers as well, if you want to deploy it on the cloud-based solutions. If you want to package it and to be ready to be used for the other platforms, such as you want to use it in Python, you can use MATLAB compiler SDK and package it as a Python package. Now, there are several central communities which are present here to help you out to get more and more MATLAB answers, file exchange, and how the community is talking about. Apart from that, there is a lot of MathWorks engineering support which is present that includes training, technical supports, and on-site workshops. There is a detailed training on MATLAB fundamentals, which is a 3-day course that is very extensive. There are few of the on-ramps as well, which is a 2-hour course to give you some kind of understanding how the MATLAB looks like, and it makes you familiar with everything. Now with that, maybe it's a time to take a pause. We have 10 minutes to handle any questions and answers. And if you are not able to complete any of the tasks, feel free to drop an email to me or approach to our to Louver here, or if you want to connect with me via LinkedIn, the QR code is there. Feel free, just say hi. I would be more than happy to talk to all of you.
Thank you very much, Garima, for the helpful information related to exploring using MATLAB for a lot of different types of analysis. Because as a part of the overall example, there are a lot of different steps that had to be implemented. So a few of the questions that were already in the Q&A panel were answered because they were related to troubleshooting. But any questions that come up in the next few minutes, if you have any questions for Garima, please put them in the Q&A panel, not in the chat. That'll help us locate those questions a little bit faster. So there's a question in the Q&A panel. I'll read it out loud. And Garima, you can provide some insight. I may provide some insight as well. So the question is, does MATLAB also generate the insights from data exploration? And if we needed to qualify anything, we could do that as well. So did you want to get started?
Perfect. So, yeah, I saw that question in Q&A. Just wanted to make sure that what kind of insights you want to get so that I can point you to the right resource.
So we'll wait for that person. In the
Yeah.
meantime, I know someone's typing an answer, but I think this is good for the general audience. Do you have any tips on how to get faster at using MATLAB?
Of course. So I think for the starting point, the low code approach is the one of the best methods how anyone who has never used MATLAB can do not only these simple tasks like data analysis, but can also do machine learning and AI, that the full, the deep learning without even writing any code. There are so many examples. But what I suggest is we should be starting with few of the on-ramps which are present. Maybe a MATLAB on-ramp would be a great starting point for you. And if someone is working on the particular topics about machine learning and deep learning, these are the on ramps which are present. These are just 2 hour quick on ramps which are present, and it is free for everyone to be leveraged, and they all are enough to make you familiar with the quick start about the low-code tools that we have.
And I just want to add, as being a MATLAB user since, I'm going to say what, the late 90s, one of the items that has always been a part of MATLAB is using the documentation. The
Yeah.
documentation has been great from the start. It's gotten even better over the years with examples, videos, and other resources too, in addition to all the resources that Garima highlighted. So that's great. And I see the person did follow up, but let's get to this other question right before it. So
Yeah.
the question is, does the on-demand training use data that is already on MATLAB?
So the on-demand training is actually what I am thinking is that you are talking about the on-ramps. So the on-ramps data or the on-ramp training, it uses the data which is already present in MATLAB, but it gives you an idea that how you can pull your own data and you can follow along the same workflows. And there is one more question I see, that is it free, or do we need to have a license? The on-ramps are free of cost. You do not need to pay anything, but you need a MathWorks email ID to access that. So a user account to access that. Correct
But
me,
I
Lou, if yeah.
Yes, so that's correct. But I also want to expand that question even further, where in order to use MATLAB itself, so you typically would need a license. What we did with MATLAB Online for this session is we created a license that's good from now until 2 weeks from now that you can use to help explore MATLAB Online. However, if you want to use MATLAB after that time, you do need a license. So just to expand on top of
Yeah.
what Garima highlighted. So that makes sense. Now, here's a follow-up. So I'm going to jump to the question that the person asked earlier, but they
Hmm.
clarified. So here's
Yeah.
what the person wrote back. So when you perform visualization and exploration, how do you actually explain what has been done to show that you can explain what is going on with your data?
Okay, I understand up to some extent what you wanted to show, what you wanted to ask. So there are several ways. There could be a statistical way how we can support our visualization or our data exploration. For example, you can see the feature extraction. This is a very common, a common workflow while working with the deep learning or machine learning part of our workflows. So there are several ways like explainable AI methods like Lime, Shapely, GradCam. So depending upon the kind of data, while you explore that data, you can use those statistical tools to find out what is happening inside your data and why your one of the maybe machine learning algorithms is performing very good and why the other one is performing bad. So if there are misclassifications, why it is happening, those statistical parameters like Lime, Shapely, and if you're working with images, then GradCam, they can help you to understand what is actually happening inside the data if we look at the bigger picture for the data science or the deep learning based algorithms.
And this is great. Just to point out, so we're going to answer this next question. For
Mhm.
the machine learning algorithms, MATLAB has the built-in functions for supervised and unsupervised learning, or we need to make the import part, similar to Python, that we have to import a library that has those algorithms. So I can highlight some info, but Garima, do you want to get started?
Okay, yeah, I can get started and you can highlight if I miss something. So in MATLAB, once you have the toolbox with you, you do not need any additional library as you need to install with Python. For example, if you want to generate a TensorFlow or a PyTorch, you need to import those libraries apart from the pandas and the other one that is used for data handling. The MATLAB base can handle the various kinds of data formats, and the toolbox, which is like machine learning toolbox, stats and machine learning toolbox, can handle the machine learning algorithms and the models. There are so many inbuilt models which are present. And if there are models which are pre-trained, they are also present in our deep learning toolbox for various kinds of applications. Like for example, we have ResNet 50, ResNet 101, and many more examples or many more pre-trained for transfer learning kind of approach.
And
Lou,
just
anything? Yeah.
Yeah, I agree with everything you said, Garima, just at a high level. So in MATLAB, we don't necessarily have the concept of you have to import, but as Garima pointed out, our pathway is through toolboxes. So as long as you have access to specific toolboxes, you'll be able to call those functions in your MATLAB code for machine learning, deep learning, and other topics as well. So toolboxes, if you have access to toolboxes, that's how you call those other pre-built functions. Okay, I'll answer that live. I just want to bring up something else. There was a question that
Yeah.
someone had earlier, and I'm going to bring this up because I know people
Hmm.
are thinking it. So we were using MATLAB to implement data science tasks, and there are many other tools that can help us implement data science tasks. However, keep in mind, in terms of using different tools, part of doing that is related to people's familiarity and comfort. And then in some cases, it may depend on what some colleagues are previously using as a part of maybe working on a project team. I do want to point out that you can use a variety of tools to perform data science related tasks. We saw that today with MATLAB. And if you are using other tools, typically MATLAB has a pathway to allow you to interface with other tools. For example, you can call Python code in MATLAB if you have pre-existing Python code. You can call code from other programming languages in MATLAB as well. So I just want to keep that in mind at a very high level, because I know for a lot of people, they may associate, oh, here's this one tool when I use, when I do a certain type of analysis, where that's typically not the case. You could perform a lot of different types of analysis using a variety of tools, but there's some factors that we may need to consider. And I see another question that popped up. So I'm a big believer in GIS. My background's in geographic information technology. So I'm loving this question here. And that's our last question for the session. When I was a teenager, we used MATLAB for GIS and survey data for the City Historical Society. How does MATLAB interface with GIS applications? Wonderful question. So in terms of GIS, geographic information systems related questions, so it entails a lot of geospatial data analysis as well as digital mapping. We have a mapping toolbox that can help out with working with quite a few of those different file formats, shape files, and quite a few others. If you wanted more information related to MATLAB for GIS, I can share my email address in the chat, or we can connect through LinkedIn. So I will do that, but hopefully that answered that question. And just doing a quick time check, we got through a lot of questions. I want to acknowledge the math workers who were here with us, who helped out behind the scenes. So thank you to Sarah, Winter, Sindhuja, as well as Elvira. And keep in mind, Winter, I know you're there too, so I was going to say Winter as well. But keep in mind, we will have the chance to follow up after the session. There are a few other topics that they want me to go through. So I first of all want to say thank you so much to Garima for providing us with all of this exciting information regarding using MATLAB for data science and a host of other tasks. So that's one. In terms of today's session, so that concludes our upskill workshop for today. We'll share the recording of resources within a week. If you'd like to connect with Garima, her LinkedIn information should be in the chat. And if it's not, please put it in there as well. Also, on behalf of the WIDS Workshop Committee, thank you to all the, I'm going to say, definitely Garima is the instructor, but everyone who assisted with today's session overall. Today's workshop was hosted by the WIDS Upskill Workshop Committee, and it's part of a weekly workshop series designed to upskill data scientists and aspiring data scientists worldwide. We do have a workshop coming up next week. So for next week's workshop, you'll hear from Leticia Nogueri from the American Cancer Society. She will deliver the workshop, Climate Change and Cancer. Let us know what you thought of today's workshop by filling out a short survey. We'll post that link in the chat. If you're interested in giving a WIDS workshop on a topic that you're passionate about, technical or professional skill building, we invite and encourage you to apply to become a WIDS workshop instructor by filling out a brief speaker application. We will also share that link in the chat. Once again, thank you so much for joining us for today's workshop. We look forward to seeing you at another WIDS Wednesday Upskill workshop. Thank you for your time, and hopefully you have a good rest of your day, and we do have QR codes you can scan. Thank you.
Thank you, Lou, and thank you, everyone. And my LinkedIn is there. Feel free to connect if you have any questions. Reach out to us. We will be more than happy to help.